My name is Bob Scharf. I'm the chair of the Numata Center for Buddhist Studies. I really want to welcome you all. And before we do anything, I want to thank our donors and sponsors, the Numata Foundation, also known as the Bukkyo Dendo Kyokai, the Glory Sun Global Buddhist Network, and the Tsadra Foundation. Without their support, none of this kind of programming would not be possible. So I want to just say a few words before turning it over to the speakers about how this particular event came about. Kurt Koitzer, who's a professor in the engineering school, has long been interested in putting his engineering and computing skills in service of Buddhist studies. And he suggested doing a workshop on machine learning and Buddhism quite a few years ago now. And I have to admit that the humanists among us were not overly enthusiastic. We had all, seen various different iterations of digital humanities come and go. But this last year, with the media hype over AI and the power of LLMs hit a feverish pitch, and Kurt's own Dharma Mitra project was coming of age. That got, Kurt finally managed to get Alex and Jake and I to sign on. And what ensued was a long discussion about what the focus of the workshop should be, as it was unclear just what the impact of AI was going to be on academia in general, Buddhist studies in particular, and whether or not we should care. In the end, this particular question, how AI might affect our field, and particularly how it would affect the training of graduate students, became the very theme of the event. Now, all of us are wary, of course, of the hype surrounding AI, of the idea that we're about to reach the AGI singularity when AI will surpass human intelligence and begin running the world. Indeed, that's why in the end we made a decision not to focus on the philosophical ramifications of AI. It's simply too quick a moving target, and it's made even fuzzier by the media attention. You need only recall the fanfare over self-driving cars some 10 years ago, when everyone seemed to agree that autonomous cars were just around the corner. In 2016, Elon Musk claimed that Tesla was 1 year away from having a fully autonomous car for sale to consumers. In the following year, while Tesla was a no-show, GM claimed that their self-driving cars would be ready by 2018. Around the same time, Waymo, in conjunction with Honda, anticipated their self-driving car would be ready by 2022. And Mark Fields, a CEO of Ford, said that Ford would release a fully autonomous car that lacked even a brake pedal or a steering wheel by 2021. So clearly getting from 80 or 90% of the way there to 100% or all of the way there is a deep problem. So we know enough not to get carried away by technology leaders, especially when the companies they represent are competing against one another for venture capital. It's now 2024, and Apple has abandoned altogether their involvement with self-driving cars. Be that as it may, AI has clearly already made an impact, although, as we all know, it's not always for the best. I have a large undergraduate course that requires written assignments every week, and I just joined a pilot project run by Berkeley and Turnitin that uses AI to detect AI-written papers. It's not clear how well it's going yet. The truth is I can't get it to work yet. And nobody at the university understands why. Now, when I was a graduate student in the 1980s, training in the field of Chinese Buddhism, which is my particular field, involved, among other things, learning to navigate a host of pre-modern Chinese and Japanese lexical works, concordances, and other resources to help get a handle on obscure terms and phrases, to look for clues as to a text's provenance, its authorship, dating, its polemical context, and so on. And these resources were challenging to use. Many of the concordances required the use of the four-corner system. You had to become familiar with the widely disparate organizational schemes of the dozens of Taisho concordances, which were all done by different universities, and on and on. And you needed not only the skill to do that, but also money. The bare minimum of a working reference library could run into thousands of dollars for a student in my area. Now, of course, even earlier generations didn't have those resources at all. They didn't have the concordances. They recognized sources and quotations because they had read a ton and somehow remembered it all. I could imagine them rueing the day that concordances would make such encyclopedic knowledge optional. So today, many of the skills that I painstakingly gained in graduate school, not to mention much of my reference library, is utterly useless. You do an on-sign search and find in less than a second more than you ever would have being able to use the old technology. But when digitized edition, people may not remember this, when digitized editions of the East Asian canon became available, not everybody was happy, because many expressed alarm about what this would mean for serious scholarship. At least, if you're using a concordance, you still have to put your hands on the original source, look at it, read a bit, figure out what's going on, kind of recreate the context. With a SAT search or a CBeta search, you might never look at more than a line or so of the text. So many would agree, I think, that the goal has not actually changed all that much. We're still in the business of deciphering and critically understanding Buddhist textual sources in their original languages so as to reconstruct the institutional, social, and doctrinal history of the tradition. This has always involved skill in classical languages, including the ability to translate relevant materials, although many in our field would argue that translation is a means to an end and not an end in itself. But what happens as AI begins to excel in translation itself? Is it just another useful tool, like a concordance or like a digitized Buddhist text that will increase our productivity, or does it foretell a more fundamental shift in what we do? And so that, in short, is what we're here to explore. We'll begin with talks by those involved with the actual design of digital tools, including translation tools, and then move on to reflect on how this may or may not affect the way we imagine our task and train our students. So with that, I'm going to turn it over to Kurt Kreutzer, who's going to chair the first panel.
Okay, thank you, Bob. So I think it's appropriate that we start with Sebastian Nerdick, because he's not only one, I think, more responsible than anyone else for bringing the latest wave of AI to Buddhist studies, but he's the one responsible for getting Bob Sharp over his deep skepticism about AI that he just evidenced for us. So Sebastian, take it away.
I'm Sebastian, and I'm going to talk about the Dharma Mitra project today and what we have been doing over the last little bit more than a year and a half now. Our team, basically my presentation is going to have three parts. I'm first going to talk about the machine translation system. The second part is going to be the Mitra semantic search system. And then I'm also going to talk about the Mitra LLM. The working title is the Alaya LLM, which will serve to provide the basis, the foundation of the different pravritti vijnanas, the functions that we are offering in order to deal with the different demands of Buddhist studies research. So that's the outline. Before I go into the individual sections, I will talk about the team that we have in order to show you what layout the Dharma Mitra team has. So on the one hand, of course, there's Kurt Kreutzer, who's the director of the team and leading the whole enterprise, and then we have myself for the technical implementation of the machine learning system and the databases that we are running. Then we have David Alport, who's here with us today, who's supervising the Sanskrit data collection and has been a very vital coordinator of our students who have been working on collecting data, the student interns and high school student interns. And then we have in India Jivnesh Sandan, who's been working together with us on Sanskrit NLP applications. And then we have two undergraduates here from UC Berkeley. One of them is here with us, Avery Chen, who are working on projects related to the machine translation system on evaluation and on search engines. So we are also very happy that we have collaboration partners all around the globe. We were very happy to host Foguangshan this summer here in Berkeley, who are helping us on developing Chinese to English machine translation capabilities on collecting data, and they're also supporting us in order to train the models that we are working on. And then we have, of course, a longer standing collaboration with Mendam AI, and here you can see the vast, huge team that we have on that end. And Nawan Tunle is here today, who's part of that team, and they have been a vital support for all of our efforts on Tibetan to English machine translation and Tibetan-related tasks. And then lastly, we are happy to work together with the Kumara Jiva project, where Shelab Chen is here today, and this team has been very vital in giving us feedback on the search system as well as the translation system. So that's also has been a very fruitful collaboration. Now coming to the individual sections, the first one is going to be the machine translation system. And here, before I'm going to talk too much about what it actually does and how it works, you can use this QR code and just go to our website and try it out yourself. I mean, there's a lot that can be said about how good or bad it performs. I think the easiest way to get an impression is just to try it out yourself and be your own judge. But I'm also going to show a small video demo on how this machine translation system performs in action. And this is, you can basically just paste a sentence here. This is a piece of Sanskrit text, and then you can click on translate. And what you're seeing here now is also it's providing a grammatical analysis of the sentence, which is a feature we are going to make available in the coming weeks also to the public. So far we have the translation part, but the grammatical analysis and explanation is going to be added very soon, yeah. And moving forward from this, we also have already online since a couple of months. I think we launched this somewhere in June this year, is a grammatical analysis engine that provides not only the separation of Sanskrit into individual words, which means the splitting of sandhi as well as the splitting of compounds, but it also provides grammatical texts like the case relationships, dative, accusative, and so on, as well as more detailed explanations of the verbal system and meanings from a dictionary that is matched against our lemmatized corpus. So coming to the technical parts, so how regarding what you have just seen, the demonstration, so the Mitra system has as main languages Sanskrit, Tibetan, Chinese, as well as Pali, and the main focus at the moment is to translate into English, but we are also working on other target languages, but the general performance into English is the most reliable one. Then for grammatical explanations for Sanskrit, we do have this feature now online and working, so you are welcome to try it out. We are also working on extending this to Tibetan and Chinese as well, and hopefully we can make it available in the coming weeks. We are currently the state-of-the-art system for Sanskrit, Tibetan, and Chinese to English machine translation, so by whatever evaluation metric we have in order to compare with other models, and I will show a bit of that on the next slide, we are basically outperforming these models when it comes to the simple translation task. And lastly, we have between 600 and 1,000 active users a day, which I think for this small field means something at least. Yeah, coming to the machine translation evaluation part. So again, the best way to measure how good a system performs is to just use it and to form your own opinion. But in order to also give a more quantified overview of how our model performs, I'm here showing the performance for Sanskrit on a number of different texts. And the different lines indicate how well the produced translations by this system is in comparison to a reference translation that we have collected from human translations. And Mitra in this comparison experiment comes out on top for basically all of the text, sometimes with a clear margin here. But then we have Claude 3, Opus, and Sonnet, which are following after that, GPT-4, GPT-4 Turbo. All of these are forming kind of a middle ground, and then we have Google Translate, which supports Sanskrit, but is clearly falling off a little bit. We have similar graphs for Tibetan and Chinese, but for the sake of time, I will, we can also see similar trends for Chinese, but here Mitra is not standing out to the same degree, but it is on average a little bit on top of the other models. Coming to the grammatical explanation engine for Sanskrit. So The annotations for this are based on the digital corpus of Sanskrit that Oliver Helwig has compiled over many, many years, and it's a really tremendous achievement that he has been working on really tirelessly for many years. And that is our instruction, or the data that we use in order to create the system. So whatever merits, or maybe also sometimes disadvantages our grammatical explanation system has, this is based on the corpus of Oliver. So there's a lot of a human component in this as well, because the way we annotate sentences, the way we do this is, of course, after all, a human effort, and that requires to come to agreements about how to do things, and that's one of the basic challenges here. We have newly released a Sanskrit NLP model that we are calling BiT5 Sanskrit, and this performs Sandhi and compound segmentation, lemmatization, and morphosyntactic tagging jointly. And this is basically what you see in action. If you go to the website, you can see how that works. This model is the state of the art for Sanskrit grammatical analysis with a considerable margin. So it clearly works the best for the kind of tasks if it's about DCS style annotation of Sanskrit. The error rate of this system, so we have done a careful analysis of how many errors does it make, what kind of errors does it make, and we came to the conclusion that it's roughly as reliable as having one single human annotator going through the text and doing this kind of annotations. We are serving the system on an API on our Dharmamitra website. So for those of you who are leading corpus annotation projects, who have the need to analyze more Sanskrit text at once, who want to do search and comparison of Sanskrit text, we can serve up to 10,000 sentences a minute if you have that need, so feel free to reach out to us. We are very happy to support projects that are in need of this capability. And in case you want to learn more about how this model is trained and how it works, we are very happy that it was accepted at the EMNLP this year. That's a computer science natural language processing conference. And there you can read up all the details of our work at this point. Moving from the grammatical explanation to the feedback on the translation and search system that I'm going to talk about later, the Kumara Jiva project helped us with the evaluation. And on the one hand, it's always difficult to find translators that really have time and want to go to the effort to evaluate such a system. Yeah, that takes time. You need to make interviews. You need to sit down and all of this. And I mean, we are all very busy people, so even just to find a handful of people who are really taking this serious is difficult. But thankfully, Kumara Jiva project helped us, and we found 6 professional translators that actually went through this process. And the summary of this is this simplified scale here on 1 maybe not working so well to 5 okay, and 10 working very well. We can see that all of the translators agree that this system is useful, with 1 giving a rating of 7, 2 giving a rating of 8, and 3 giving a rating of 10. So, I mean, this sample size might not be the biggest, but it certainly is an indicator that this system is perceived positively. Now, moving from the Mitra translation system to the Mitra semantic search system, in order to explain what we want to achieve with that, I want to go back a little bit to my own academic time at Hamburg University, where I was tasked with the reconstruction of a damaged manuscript. In this case, it was the Madhyanta Vibhaga Tika. Some of you might have encountered this text at some point. And as you can see, about 1/3 of the manuscript was burned badly in a fire. And the task is to reconstruct those missing segments here. And this is basically a translation task from Tibetan to Sanskrit. So that is kind of what I got in 2017. And I was very excited to start working on this. The good thing is it's really a problem statement is quite simple, because the manuscript otherwise is very beautiful. The writing is very clear, and the quality of the manuscript is very high. So if it wasn't for that burn part, that really makes things difficult. So we have about 30% of each line is actually lost. And when I met a friend at that time who is still a professor for computer science in Germany, he just looked at me and said, well, this is actually a great problem to get computers out. So how did that happen? So first of all, the gaps that we are encountering are generally not too large. So we are not talking about full pages that are missing, but we are talking about maybe half a sentence here, maybe only a few words there. And that really makes the search space much smaller because we have hints of how the sentence might be structured because we are not missing the whole thing. Then we also have a complete and very high quality Tibetan translation, which is of course great because that can guide us through the back translation / reconstruction process. And of course, recently, and that's ongoing with every year, some new texts are being added. We have Abhidharma and Yogacara material in Tibetan and Sanskrit that are related to this text that might be from the same author, from Stiramati, or from important related authors like Vasubandhu and others. So really digital material is increasing and increasing for this kind of task. And the previous editions like Yamaguchi in the 1920s, I think they didn't even have the Abhidharma Kosha Bhashya at that time in a usable edition. So this is of course a very fortunate situation. And lastly, I want to mention that in many cases, actually evidence from within the same text can already help us a lot in order to get ideas on what these gaps might be. So coming from this specific problem, we have more general problems that we can abstract and that we can see that need to be addressed in order to make efficient efforts on the reconstruction here. So the more general problem that I have seen when I started this work is, okay, actually, we need to find related passages across different texts in different languages. So many times I had to check up how a certain Tibetan translation of another text handled certain vocabulary in order to know how I could fill in the gaps in the Sanskrit. That was the main task. It really became something like a game at some point, just to look up, okay, where's this group of Tibetan syllables appearing in the Abhidharma Kosha Bhashya, then look back at the Sanskrit, oh wonderful, I found another fragment that is matching, and I could really just puzzle together the missing pieces. It was great fun. But I realized at that point, okay, this is actually a general problem that in our discipline, I might not be the only one that is encountering that, yeah? And I think probably many of you are working maybe on Chinese texts, you have the need to look back into Sanskrit equivalents of your passages frequently, and yeah, so how have we been doing this so far? The method that I was taught, and this is not to blame my teachers, I think it's really what people just do in order to address this problem, is to use a pocket calculator and then to apply the rule of 3. So you have a book with 250 pages in Tibetan, you have one with 100 pages in Sanskrit, and then you calculate on which page of the Sanskrit you find your sentence, and then maybe you have to look another 3 pages ahead and before and after, and then go up and down, and then maybe after half an hour you know, that's where I wanted to look at. And that's kind of what I found myself doing most of the time, is really flipping through e-text, calculating roughly where I need to be, and then again scanning up and down for maybe just 10 minutes, sometimes half an hour, to really find the precise part that I was looking for. Fortunately, we also have digital resources for this. So there's the Bibliotheca Polyglotta, which is a great resource of manually input parallel text, Sanskrit, Tibetan, Chinese. But the problem with that is that for the work that I was doing, there was practically not much relevant material, at least at the time in 2017. It might have improved in between. But at that time, the Yashomitra's commentary on the Abhidharma Kosha Bhashya, for example, was missing, and that was one of the biggest resources that I used for my reconstruction. So basically, a great idea, and putting this in manually is a whole lot of work. At some point, I actually started to do it myself, and I could not do more than 100 sentences a day, otherwise I got very dizzy, and then I calculated, okay, if I continue this my whole life, maybe at some point there will be enough to do this job, but maybe we can do it in different ways. Yeah. This leads to another related problem. So finding a similar passage to a given input phrase within the same language, allowing for some variations in orthography and vocabulary. And in this presentation, I'm not going to go in too much detail on this because we basically published that work in the Buddha Nexus project at Hamburg where I worked before. So that was another outcome of this line of questions. And that's, of course, the easier problem because we don't have to think too much about how we handle semantic embeddings in different languages. And lastly, of course, and this is kind of when I met Kurt Keutzer for the first time online, he mentioned this, but you can also build a question and answer system. And I was like, well, what is that actually? I was in Germany at that time, really not really connected with the current ideas and concepts in Silicon Valley, but basically the idea you have an input in English and you get an answer in Tibetan or in Sanskrit. So you can basically, based on a query, on a question, get something out of the canon that addresses that question. And at that time, it sounded like fantasy to me, and I was like, okay, that would be amazing, but how can we even do that? But actually, it is something that slowly, with the advance of technology that we are seeing, becomes more and more feasible. And I'm going to demonstrate a bit of that later. So what is our solution to all of these problems that we are proposing now? So we have developed the Mitra search system, which is currently, let's say, an early alpha review stage. So we are looking for testers, and if anybody here is interested to be a guinea pig and try it out and give some feedback, we are more than happy to have people try it out. But we hopefully are able to make this available to a broader audience in the not too distant future. And what we have at the moment is an interface which looks pretty similar to a standard search engine that, maybe most of you are already aware of from internet search. You can enter a term here, you can push a search button there, and then you will get results. And again, so that's the interface part. Then this is an overview of how these multilingual results in our system at the moment look like. And here's a research question, again, something that came up in a seminar in Hamburg many years ago. And we were wondering about the question whether it is actually possible for an Arahat to still have moments of mental instability. And actually, the Abhidharma Kosha is talking about this. And our system here finds the results of this question then based on the Chinese translation in Paramattha, where it's actually said that, yeah, this is possible if the four elements are not even. And this is also, here's then the corresponding Tibetan passage that discusses the same topic. So this is matched in our database and searchable via English queries. And here you can also see the same passage matched with the Sanskrit parallel down here. Yeah, so that's our solution for this lookup problem of parallel sentences. And I will give some statistics on how much data we have collected on later slides. I can also show a live demo of our search system at this point with a different example. So this is one verse that I think the Prasanapada as well as the Abhidharma Kosha is citing about the suffering of ordinary beings, which is compared to a hair that is placed on the hand. So ordinary beings don't really notice that, but when you get it in the eye, it becomes very painful. And it's a common example. It's cited quite frequently in Tibetan literature, and our system then produces the results in the original language, but then you can also click on an explanation button that will give a summary and will explain how this result then relates to the query of the user. So it's a translation and summarization task at the same time that our language model here is performing. Yeah, so to come to the individual ingredients of our search engine. So on the one hand, we have the input, which could be English, Sanskrit, Tibetan, and other languages. That's what we are accepting. And then we provide the filter options. This could be, of course, filtering by language, but then also by collection, by category, and even down to the level of individual text, which I think, depending on your research topic, might be very relevant in order to say, okay, I only want to search in, for example, the Trimshika Vignapti Bhashya, and then only results from that text are actually produced. Then we are first showing the result in the original language, so that's what we are putting on top. And the explanation and summary is more of an optional step that users can do if they want to, but it's not strictly needed. So, yeah. Now, coming from this part, of course, this functionality requires a lot of technical solutions on the background that are conceptually a bit more difficult, but I will still try to explain what we are doing on the background. So the main innovation or new part that we are bringing here to the search system is what is commonly called semantic search. And semantic search differs from keyword-based search, which is the more traditional way on how to search things in the internet in larger text where we type in keywords and then get results on that, while semantic search is looking for the query's intent, for context, for semantics, and then tries to use a more rich embedding strategy in order to find the target. In order to show how these systems differ in detail, so keyword-based search produces limited results that match the precise wording, while semantic search gives more general results that can actually be relevant even if the wording differs or totally different phrasing is used. Keyword-based requires segmentation of the text into searchable units. This for Tibetan and for Chinese is not so much of a problem because we have characters, we have syllables, we can just start right away. For Sanskrit, it's a huge problem, and I think that's also the reason why until now we don't really have good websites where you can just search in large Sanskrit collections, because the implementation of that is actually not trivial. Semantic search requires training of embedding models, which then again require training data. So in order to create this embedding model where we can map semantically similar concepts into the same space, we need to give the system input in order to learn that. And that, of course, requires data collection efforts, and that, again, is much more work-intensive and difficult to pull off than to create a keyword-based search system. The advantage of keyword-based search is, of course, it's easy to implement, it's fast and simple in deployment, while for semantic search we need to do the training of models, which is challenging, that requires a lot of computational resources. Keyword-based search, by definition, is limited to the same language, so we can look for the same phrasing in the same language. We cannot really go across languages, while semantic search models can be trained in order to search across different languages. Now, to give one example of how we do syntactic search or keyword-based search, syntactic is another name for that, for our Dharma Mitra project, I'm going to show you how here the search term is Arya, and then it's actually able to find Arya also if it is in a morphologically different form, in this case Aryanam, the genitive plural, and also when it is embedded as a compound here as Arya Satyam. So in order to make this possible, we use our grammatical Sanskrit engine that segments the text and reduces it to the morphological base form. And then this makes it possible to find terms that are embedded in compounds. It also makes it possible to find terms with different inflected forms. And another advantage is that this makes it also possible to find terms regardless of sandhi changes and orthographic variations. So this really is then bridging the gap that enables search of Sanskrit terms across the whole corpus without worrying about what the sandhi might do and so on. Now coming to the layout of our whole search engine, that is of course a bit more complex. There's no need to really understand all of this. I just want to give an overview of what different parts are used for this. So we have a search query at this point, input, which could be what are the Four Noble Truths. In this case, then, in the first step, we might do a machine translation if that's necessary. If we have an input in Japanese, in French, or in another language, we might use machine translation in order to bring that into English. And then we have different retrieval systems, and the trick here is really that we are combining different approaches at the same time. So we have vector embeddings for the semantic search, but we also have traditional search that is using BM25, and we combine these different approaches in order to give a comprehensive search result. And then we do ranking and filtering of these results in order to order them according to the relevance, that the most relevant result is coming up on top. And if the user is applying filters like I only want to have results from the Pali Canon, maybe only from the Digha Nikaya, then of course those filters are also applied in order to make sure that the results are only what the user is actually looking for. Coming from here, we have the results, which are presented as a list of the primary or the primary language results, which you have seen on the earlier slide. And then we have the optional step of translation and summarization that the user might decide, okay, I want to learn more about this result. I want to know how it relates to my search query, so they can click on that button and get that explanation if that is needed. Yeah. Creating the vector embeddings for semantic search, again, is a complex task, but just to give a short overview of that. So we have our input text here, which could be in Sanskrit, in Chinese, or in Tibetan. And in the first step, we are segmenting these into paragraphs in order to have manageable units. We use a special deep neural network for that. Then in the second step, we embed these into vectors, which basically just means we turn these into high-dimensional numerical representations, so a lot of numbers. These numbers make no sense for humans to read. They are just very complex, long numbers, but they are produced by neural networks that are trained on finding semantic similarity means. So in that way, we create these paragraph vector representations. And now on these slides, I'm only showing 5 of these, but our database is actually holding 15 million because we have all that data that needs to be embedded here. And then lastly, we put all of these in a nearest neighbor search index, which means we can actually query an incoming embedding and look in that index for which is the most similar embedding to this incoming embedding, and then retrieve these in order to show the users, okay, for your question, the most similar answer from our database might be this list. And that's how we end up with the search results in our case here. Now coming to the last part of my presentation is the basic ingredient that make all of these different applications possible. This is the Alaya LLM. And our training mix is this chart that you see here. So this is a basic language model that we train on a lot of different data in order to make the downstream applications, including the machine translation model, possible. So we have this base model of the Mitra project, which totally was trained on 6 gigabytes of data. For those of you who are a bit more working with machine learning algorithms, this is 7 billion tokens in that language. It's quite a lot, but it's not really much compared to what maybe Google or OpenAI might use in order to train their language models. They might use 1,000 times more data. Our data is mainly English data that we have taken from OCR efforts on archive.org, as well as collected publications from academic sources that are relevant for Buddhist studies and the larger connected fields, Indology, Sinology, and so on. We have Tibetan and Chinese data that is taken from the traditional collections of Buddhist scriptures and treatises. And then we have Sanskrit and Pali data, which is, on the one hand, we are running our own ongoing efforts of OCRing and collecting data, but we also use various eText repositories that are freely available and that we use in order to increase our data coverage. And then you might see here also our parallel data section, and this I'm going to show on the next slide. So parallel data is basically the data we are using in order to make multilingual tasks possible. So this means a sentence in Sanskrit and the English translation. That is a parallel data point on sentence level. And this data is showing an overview of how much of this data we have for the different languages. So for Tibetan to English, we have almost 2 million. That is a huge collection. For Sanskrit to English, we have more than 1 million. And for both Pali and Chinese, we have about 250,000 each. And we are very happy about our collaboration with Mönlam AI here, who helped us to get to the 2 million points here. We are very happy about our own student interns and the efforts we do here at UC Berkeley in order to collect the 1 million sentences for Sanskrit. And then lastly, individual Pali scholars have contributed on this end, and we also have the help of Foguang Shan in Taiwan to increase our data coverage for Chinese to English. This then leads to the next data point, which is the parallel data between the original languages, in this case Sanskrit and Tibetan, Sanskrit and Chinese and Tibetan. And this data is of course not only interesting in order to train language models, but it's actually interesting as a philological research database on its own. And here we are very happy for the Kumara Jiva project, which has helped us to bootstrap this data collection by providing Chinese-Tibetan manually aligned data, which we could then use in order to train a language model that could find the remaining data between these collections. So we have an ongoing work on this. There's an automatic algorithm that fetches this data from the traditional collections that looks for similar patterns and will extract parallel sentences. I hope to publish the paper of our research group at some point next year. So far, I can only show you the statistics that we have around 600,000 sentences between Sanskrit and Tibetan, 280,000 between Sanskrit and Chinese, and 860,000 between Chinese and Tibetan. So this really makes it possible to look up how a specific Tibetan sutra, how the equivalent to that in Chinese at a given position looks like, without the need of actually searching manually for the corresponding passage. Yeah, this data is, as I said, not just useful for model training, but it also is a parallel reference corpus for philological research. The last part that I want to demonstrate is the Mitra instruction data set. So while we have the R-layer LLM, our basis, on the one hand, we need to have also individual functions of this system. And this is where the instruction data set comes into play, where we instruct the LLM in order to perform specific tasks. And this is an overview of the different tasks we have. And to go in more detail through the individual tasks, we do have the translation and explanation task, which is what you saw in the video earlier. This means not only a translation, but also to give annotations based on annotated tree banks that then make the translation more understandable to the users by explaining the meaning of each word, the grammatical function. So, because in many cases, just getting a translation out of such a system is not really what the user is looking for. They also want to have opportunity to really dive into the meaning of each word and to understand that. Then we have document level translation, where users might want to translate longer paragraphs, maybe whole text at once. So this is also one task we are training our system on in order to have more capabilities of context beyond individual sentences. Then we have a bit technical term KNN translation, which basically means we allow translation which is informed by existing examples from reference translations. And this again offers the opportunity to narrow down these reference translations to a specific author, for example. If one wants to translate in a certain style, one can give a reference from a specific author, and then our system is going to follow that style. So that's the KNN translation task. We also have cross-lingual summary, and that's what you saw in the video earlier, that we give an input in Tibetan or in Sanskrit, and then the system is creating a summary in English, which also explains how this example is related to the user query. And lastly, we have cross-lingual term extraction, a bit clumsy term, but this just means we have a text, we have a search term, which could be in English, in Sanskrit, Pali, or other language, and then we find the corresponding term in a target text in language B. So this again could be Tibetan or Sanskrit or Pali, and then we can highlight where that input search term is showing up. So this makes it then possible to find translation terms in a longer text. Our language model is going to be available open source and on Hugging Face. For those of you who are doing machine learning experiments, you can actually go to this Hugging Face repository of our project and just download this and start playing around with this in LLM Studio on your own computer if you want to. That's all possible. And then the question is, okay, this is an overview of what we are working on right now, and some of the features are already on the Dharma Mitra platform. Others will hopefully come in the coming months. And what is the longer term things that we are working on that we might be able to provide in the future? So on the one hand, I think very important for us is to see how we can combine the search system and the translation system in order to provide translation with references and context. Then also to have spell and grammar checking of the source language. This is kind of a trivial need, but it's also very important that sometimes we have errors and mistakes in the Sanskrit and the Tibetan, and we want to check that first before we actually start to translate, because otherwise the translation might turn out to be totally off. And then one thing that I'm myself dreaming of for a couple of years that brings us back to the Madhyanta Vibhaga Tika is, can we create something like a philological co-pilot where we are actually reconstructing gaps in manuscripts based on abilities of these large language models? Because maybe humans are, after all, also just language models that are trying to fill in the gaps in a text, and in that way I think there's some overlap between what an LLM is doing and what we are doing. And in that sense, I think there's all the reason to be optimistic that we might be able to provide language models that can do this as well in the future. For example, to mask parts of a sentence and then train a model to reconstruct those parts. and also to do a guided reconstruction where we use possible variant readings, parallel passages from other texts, and so on in order to make more informed decisions on how emendations and how improvements on the text might be performed. This raises the question, will it finally be possible to automatize the reconstruction of a text like the Madhyanta Vibhaga completely? My opinion is the human will stay in charge of this task for a long time to come, but we can step by step provide the tools that make each of the steps needed much quicker, much faster. And just as programmers are using copilots in order to program faster, I'm confident that these tools that we are developing here are also helping to make philological work both faster as well as more precise and reliable. Yeah, that's my presentation. Thank you all.
Okay, we have time for questions. Don't be shy.
We can pass the mic.
Yeah, we'll pass it around when we get some questions. So maybe I'll do a classical nerdy question, which is, what's been your biggest technical challenge other than competing with all my other researchers for computing in this space, which is a constant battle? What has been your biggest technical challenge?
The technical challenge, I think it's always easy to come up with something that gives impressive examples and that is something we can demonstrate. It's very difficult to get consistent behavior on all of the capabilities that our models are providing. So to have a system that translates a certain group of Tibetan texts into English reliably is doable, but to have a system that is always reliable and that never makes mistakes, that is where it becomes very difficult. And the same we are experiencing for the search function. So in many cases we are, I think, all happy and surprised, okay, this really finds things that we have not found before, but then it's always those cases where we think this must show up, but it's not happening. And the question on how we can fix those remaining 10%, this so-called last mile question in AI and machine learning, this is really the part where most of the work and most of the frustration is happening. And that's not different for our project.
Just a quick question. Is it possible, do you see at some point in the future, where these generic LLMs that, AI, and Meta and so on are using, will actually catch up where all of the effort that you're doing to mark up text, to train your data will become some, you know what I'm talking about?
Yes.
Do you see them
Yes.
kind of catching up anytime soon?
To be very honest, we are already seeing that today. And we have seen this with Claude's abilities to translate Tibetan to English. I think just a few months ago, we were very confident that we are actually the only, together with Mendam AI, the only provider that has this capability. But Claude right now is doing a really good job. And I think it's really up to your own preference if you say, okay, Claude is a bit more the way I would like to translate it, or Mitra might be doing better. I mean, in metrical terms, we can show that Mitra is on average a bit more reliable and closer to how humans would translate. But Claude is, of course, very comfortable to use. It has the ability to ask follow-up questions, so that is already happening. But I do believe that the whole part of validation of results, and that means search results that bring you back to the actual source text from the tradition, where we actually interact with Tibetan material and not just an LLM outputting what looks like Tibetan, where we have no idea if this is actually an original reading from a text, but we're actually leading the user into the database in order to read the things themselves. And as much as all of this stuff is helping people to understand, I think the main point is that it's only really meaningful to work with it if we still have the language abilities and the capability to judge the quality of these results. And in that sense, I think providing this verification and validation part that leads people to the source text and to interact with the original content, that is something that I don't see Meta or OpenAI or Claude do for the next 10 years. They are just not interested in that. They believe we build the bigger LLM, it's going to be so precise, this question doesn't matter anymore. And I am not of the same opinion.
I think in some ways you just responded to one of the concerns I have, which is basically the quality of the translation data that you're already working with.
Yeah.
So presumably the sentence pair training data is based upon existing translations.
Right.
And I'm just wondering if you have concerns about the quality, certainly, let's say, in Tibetan, I would say Sanskrit as well, the quality of the translation of Buddhist texts from Tibetan into English or Sanskrit into English. Whether you have concerns about that on the one hand, and whether you try to do anything about it on the other.
I mean, to be honest, I always feel very like there are two souls inside me on this, because I was educated in a very high standard, strict philological school where even available translations are generally not regarded very highly. Yeah, okay, you are doing text critical work, that's great, but translation, nah, that's more like a side effect. And most translations are bad anyway, so don't spend your time on that. That was how I was educated. That was the attitude of the teachers I interacted with. But on the other hand, I'm also, the more I get into machine learning, the more I realize that providing generic solutions that might not always be perfect is a great service to people who are learning the language, who are in the process to getting there. And I think what we are seeing is, of course, there are bad translations, and we can't really go through those 2 million sentences and filter out all the bad translations. So that level of quality control is just not possible. So what we are doing is just the statistical approach basically helps us to filter out what is really bad, because the way LLMs are trained, they are kind of converging to an ideal point in the middle where, yeah.
Unless there's converging to an error that everyone's making.
That is the point, and there's where the human then comes into play. So if an error is really something that humans agree on, then what can we do? If everybody decides to be wrong about this, okay, our LLM is not going to stand up and say, but you are all wrong. That's just the way these models are trained. No. The statistical approach will just reproduce that, and that's a limitation that we have. I see that, yeah.
So this sort of follows from John's question. So a couple of more technical questions. So what is the size of the embedding matrix, one, and the size of the context windows? Because we know this LLMs, the wider the context window, the bigger the context window, the better the results. Also because you are running the model through different chunks of of text. So have you tweaked the values for the context window and found out that as you scale up, the results are better? So that's one the first question. The second one is kind of a follow-up.
Why don't we take them one at a time?
Okay.
I mean, regarding the context window size, I mean, this is really a very hot ongoing research topic, and I'm sure that other members of our research group at Bayer are much more qualified to answer this. And there are really people churning papers out of this on a weekly basis at the moment on how we can increase this. We work with the best that we can do, which is 4,000 tokens at the moment, Gemma 2, which I think is for hyperscaler deployment. I mean, Claude might do more, and we all know that, but on the resources that we have, which are considerable, 4,000 tokens is really not bad. I think that's a very good situation. And our embedding vector size, the matrices are 1024, and we are using tricks just as everybody else in order to work with the limited content window. So we retrieve samples from the results, then we re-rank them in order to filter out bad samples, to reduce the amount of tokens we are using in order to at some point have as much relevant information as possible in our 4,000 tokens that then can help in order to create the answer, the search results that we are looking for. Yeah.
And the model is fine-tuned on the best translations available, or?
It's translated on pretty much all that we could get our hands on, but we also have refined fine-tuning stages where we use higher quality data. So we start on the total available training data, and then we have a second stage where we filter out parts of the data and focus on more high quality. That's our approach.
There is some curation in the translation.
Yes. Yeah. For sure. Yeah.
Something about how is it validating what is fundamental in the translating language?
Okay. Yeah, so for this we are using reference translations. So we use reference translations of Pali text both to train the model and also to check the quality of the output. So we take a certain percentage of our training data. This could be translations by esteemed scholars, for example, Biko Bodhi, who have helped us with data. Biko Analayo was always very helpful in supporting this. And they will we use these reference translations, and then we look how are our predictions doing, what is our model doing, and how does this compare to the references that we have held back during the training process. So the model hasn't seen this. So there's maybe 5% of the data the model has never seen, and then we are looking in the evaluation part on how does our model output perform with this unseen data. And this gives us a rough estimation, and it's of course really just an approximation of how good the quality really is. It's difficult to know ultimately because we really would have to check each sentence. That's not possible. And again, I mean, you will notice this. If you use our system, it will make mistakes. And it really is, by the nature of the technology, currently not possible to avoid the system of making mistakes. We only can try to improve the system, and that's where our evaluation data comes into place.
Hi, you mentioned a pretty large volume of Tibetan scripts that are going into this. Is that exclusively the primary script Ichen, or does it also include Ume and Kyrie, the other variations in scripts that are common, I would imagine, across all these languages?
Yeah, in the current stage of our model, and we are trying to expand the training data at the moment and to be more comprehensive, but we have really mostly focused on the canonical collections, Kangyo, Tengyo, available from the ASIP, and some related data collections, but we are not really branching out into that territory of Ume at the moment. Yeah.
Yeah, I think you need to clarify the question because we're not doing OCR, right? So
yeah, we are not doing our own OCR efforts. For that, we work together with Mönlam AI, and we hope that we can extend our data coverage. But yeah, at the moment, we are limited to those collections. Yeah.
Okay, thank you very much for everything. Everything seems impressive. If I understand correctly, there are three main functionalities where we can use artificial intelligence, which would be translation, search, and reconstruction.
Yes.
So translation and search, the rest of me look very visible.
Yeah.
But I was wondering about the reconstruction text, in particular, on the basis of the example that you gave. Because, you basically said that most of the reconstruction was premised upon a Tibetan counterpart.
Yeah.
So what if that particular 30% of the text is not the same as this Tibetan?
I mean, that is of course possible.
So
and
potential risk actually reading into the text something that is not there in the first.
that risk is of course there. I think that's obviously, I mean, the whole idea of reconstructing this Sanskrit text based on the Tibetan is risky. Yeah? And I think we can all say the best we get out when we do this kind of work is a hypothesis of how the Sanskrit might have looked like based on the Tibetan. So it's never going to be a replacement for whatever the Sanskrit might have been. And I think it's just clear to be precise on what this product actually is, and that's a reconstruction based on the Tibetan, which mirrors what is in the Tibetan, right? Yeah, it might be closer to what the Sanskrit originally have been if we are using more evidence that AI will then help us to gather. Yeah.
okay, maybe one more question.
Thanks, Sebastian. I just had a quick question about your ranking of the search results. Is there a way to tailor that with Dharmamitra, so say based on a genre, for example?
You mean that you want to have results from a specific genre first?
Yeah.
Yeah. So, I mean, this is a very desirable functionality and very important for if we want to look at, for example, texts from the Madhyamika tradition, from the Madhyamika genre, for example, or Yogacara. And we are building this in based on the genres that we have in the text collection. So the Kangyo, the Tengyo, the way they are divided into categories, that is something we can provide as a filter here. And we also have our own taxonomy for the Sanskrit material to divide it between Yogacara, Abhidharma, Madhyamika, and so on. And for Chinese, we follow the layout of the Taisho on this end, with all the merits and maybe also disadvantages that this has. But providing this taxonomy is a very challenging task, and there can be, again, it's a lot about humans agreeing on how to classify something, and that's not always easy. But we try to follow the traditional categories in this regard. Yeah.
Okay, well, thanks, Sebastian, again. As Bob alluded in the beginning, this whole machine learning and AI thing has not, it's been like a 20-year overnight sensation. And for some of those who go back farther, very happy to have Professor Michael Radich from the University of Heidelberg, Professor of Good Studies.
Thanks very much. Good afternoon, everyone. I'll just mention quickly, I just figured out it's after midnight in Germany, where I came from yesterday, and I'm a jet lag wimp. So if I kind of feel slightly stoned, and you might be getting a slightly stoned version of me, if I'm incoherent, I apologize. So thanks very much to Bob for the invitation to participate today. Thanks to Sangjot and her team for all the organization. I was a bit alarmed, to be frank, when I saw that I have been included in a section of the program today that promises advanced computational methods. I understand, of course, that there's an imperative to make the program for a conference like this look cutting edge. And I think it would hardly be exciting to advertise the application of bog standard or retrograde computational methods to the analysis of Buddhist texts. But now that we're in the room, and to forestall any disappointment or sense of bait and switch, I would first say this. If anything, the work that I'm going to present today falls at the opposite end of a spectrum from advanced, and in conceptual and methodological terms, it's actually rather primitive. I also fear that it might fall at the opposite end of a spectrum from artificial intelligence. As I will explain, a lot of the intelligence that I did apply was human and old-fashioned and hardly artificial, and I'm also not that sure that I was very smart. So it might be more accurate to describe whatever my work achieved as a product not of artificial intelligence, but of natural human numbskullery. In any case, my only claim to inclusion in a conversation on a topic like this, that of this conference, is that I've spent, indeed, most of the past decade slaving away at an analysis that applies computation to a single problem, the ascription of texts in the translation corpus of Dharmaraksha, or supposedly in that corpus. My only choice, once I'd accepted the invitation to this workshop then, was to describe that work and then attempt to start a conversation reflecting on the implications that it might have, if any, for directions in future work applying so-called artificial intelligence to problems in Buddhist studies, or conversely to problems that we might encounter in the attempt to embark on such work, and limitations in what we might expect on the basis of past experience and what we can currently see about computation. My talk will thus accordingly be divided into these two parts. First, I'll tell you what I've done, and then I will briefly consider its implications for our joint topic. I should also say that Sebastian has already anticipated answers to some of my questions, so I'm just going to have to go ahead and be dumb and ask the questions anyway. So first then, what I've done. Given limits of time, I will be very schematic and brief. The Chinese Buddhist canon is teeming with untold problems regarding to the attribution and provenance of texts. This problem is arguably still underappreciated, at least if common practice is any gauge. Received descriptions should always be handled very gingerly and rigorously audited before we build any arguments upon their base. And yet in practice, professional scholars still far too often skip this due diligence and build arguments on the basis of received description and the dating of texts that they imply. Years ago, it occurred to me that it should be possible to harness computers to coordinate large-scale searching of the digitized corpus in order to better come to grips with certain foundational research problems like ascription. Eventually, I met my programmer friend, Jamie Norrish, and together we built some simple machines for that purpose. Whenever I say today that we did this or that, I mean Jamie and myself. It wasn't really me alone. We called the suite of tools that we made Tackle, for reasons which are now obscure and perhaps should best stay that way. Tackle has various refinements built into it, like dials and gauges that allow us to fine-tune the output to various ends. Over the course of our years working on these problems, we also sacrificed many months on the altar of irrationality and irregularity in the way that C-Beta's corpus is digitized. We also restructured the corpus to reflect better the present state of scholarship, rather than the ideological and implausible image of the canon constructed and bequeathed to us by tradition. However, for our purposes today, we can set aside those complications and work with a radical simplification of what our software does. Conceptually speaking then, Tackle allows the user to arbitrarily define two or more groups of text of any size up to and including the entire digitized canon. In my examples, I will talk about two sets of text simply because that's the conceptually easiest case. We then perform simple comparisons between our two sets of texts, comparisons of two types. So first of all, we can either find the intersection, all material shared by the two groups, or we find the difference, all the material found in only one set of text, but not in the other. And so when I speak of shared material, I mean here n-grams, that is to say, strings of encoded Chinese characters. At bottom, that's it. That's all we do. That's only half the story, however, because of course it also matters what we do next with the results discovered by our tests. I speak of this step in my work as the philological Buddhological method for the use of Tackle. Today I'll talk about only one of the two main use cases, which is at issue in my Dharmaraksha study, ascription. Again, I will simplify as much as possible so that we can keep our eye on the ball. When I use Tackle to assess ascriptions then, I first create two benchmark corpora, one for the translation group under study, and another for a contrast group, which comprises as many pertinent close neighbours or points of comparison as possible. I then perform a difference test between the two text sets to discover n-grams found only in the target corpus and not in the contrast corpus. In this case, that means strings found only in Dharmaraksha, but not in any other reliably ascribed text between the beginning of translation with An Shigao in the 2nd century and the time of Song Yao's Chusanzangjiji in the 6th century. Sorry if that's too technical for some members of the audience. In order to maximize the chance that I was discovering regular features of Dharma Raksha's phraseology and not wasting time looking at one-off chance strings of text, I set a threshold that required all results to recur in a minimum number of Dharma Raksha texts and a minimum number of times in total. So when I performed this test for Dharma Raksha, the first challenge that confronted me was that the results were ludicrously copious. Prior studies of ascriptions based upon internal evidence like this, including some well-known reascriptions that are now generally accepted by serious scholars, have virtually never adduced more than a few dozen items of phraseology to support their arguments. My tests for the Dharma Raksha corpus threw up literally thousands of strings that occurred regularly in his works, but not in the contrast corpus. So then the second challenge that confronted me was that some of these recurring distinctive strings did not look meaningful to a philologically trained human eye. Instead, some items look like the examples you see on the screen. If you don't read Chinese, I apologize, but things like this 转当, for example, or 以所, jiar, which really look like just chance combinations of random characters. Our instinct when we see such things is to say that these combinations are the products of mere chance. They don't look like meaningful units of language, and we find it hard to imagine that they could serve as evidence of style or of ascription. You can see this right away if you read Chinese, I'm sure. For those of you who can't, an analogy in English might be this example here at the bottom of the slide, fourth conversely. Imagine if I told you that fourth conversely is a hallmark feature of Charles Dickens' style, for example. You would say, what on earth are you talking about? I provisionally call such items juxtapositions, and I will return later to the problem that they pose. For the moment, my first point is that, as you can see here from the CV reader results on the slide here, so these are search results for the highlighted item, E-score. Sometimes such strings cluster very tightly in only a single corpus and a few neighboring texts in all of translation history. This is the same pattern that we see, the same pattern of behavior, if you like, or the same distribution as items that we would more easily recognize as markers of a given translation group. And a good example of that is this set of rare translations of the name of Manjushri, the Bodhisattva, which are also extremely tightly concentrated in Dharma Raksha and almost nothing else in the entire universe. So I was confronted with this problem that I had these meaningless looking strings and I had a huge amount of evidence, and I made a fateful decision. I decided to use human philological judgment and curate the evidence set that I took to be diagnostic for the hand of so-called Dharma Raksha in a translation, mainly in order to exclude these dubious cases of so-called juxtaposition. That decision required me to examine every candidate item of potential evidence in context, in numerous texts, to assess what each item meant and whether I believed, as a philologist and a Buddhologist, that it looked like evidence by an extended version of the usual criteria that are applied in prior studies. I say that this decision was fateful because the resulting work took up pretty much all of my research time for 3 or 4 years. In the end, I wound up with over 3,000 items of evidence in my evidence set, and I looked at tens of thousands of contexts in order to figure out what I should include and exclude. The 3,000 items I landed upon in the end, I took as constituting a signal, or a signature we might say, of the Dharma Raksha translation group. So in this sense, because of this moment of judicious selection, I think that we should say that the evidential basis of my work did not comprise data. Rather, we can use the term capta, even though it's an ugly neologism. Simply put, the distinction is that data, as the etymology of the word suggests, is what is given to us. For example, the results of an objective procedure like the Tackle test. Capta, by contrast, to quote Lanigan, who's one of the people who introduced the term, is that which has been taken as evidence, or that which is taken in analysis. It's that which a researcher has grasped or comprehended or apprehended as meriting consideration in evidence. So alternatively, if we want to use simpler terms, we might say that I work with curated or qualitative evidence. And that's the main thing that I meant in the title of my talk today when I said that my methods are cyborg. They were achieved by a carefully designed mix of computation and traditional human philological work. And I'll return to this point later when I consider possible lessons of my experience for the application of so-called AI. So, returning to my process of analysis, my qualitative assessment of my evidence set led to my third big challenge. The perpetual worry with such qualitative methods, of course, is that the evidence is in the eye of the beholder, and that careful selection of the evidence has yielded a biased yardstick. I therefore allowed myself to be persuaded by Lee Sang-Yup that I needed to vet my evidence set with a rigorous statistical test to safeguard against such bias. I'm skipping over a lot of wailing and gnashing of teeth at this point. This was late in the process and it caused me much more pain. In consultation with Lawrence Anthony, who's well known for his work in corpus linguistics and application to Asian languages, I determined that the current standard in corpus linguistics is apparently a log likelihood measure adjusted by what's called a Bonferroni correction. I won't go into the technical details of these measures. I confess, in fact, that as a non-statistician, I don't fully understand them myself. But the main point is that the main critique levelled against the measures in question, especially this Bonferroni correction, in the literature of corpus linguistics, is that it may be too conservative and it may exclude real evidence. So I was really trying to make my safeguard as stringent as possible. And once I applied the statistical test, out of my original hand-picked set of 3,000 plus markers of Dharma-Raksha, I still had over 2,500 that were counted by the statistical test also as highly probably significant. That is to say, their distribution was extremely unlikely to be the result of chance. I took then these markers as my final Dharma-Raksha signature. That's the 2,500 that were among those I'd selected qualitatively and had then passed the statistical test as well. I contend then that the combination of such markers, many such markers in a single text, constitutes an extremely strong case that the text must be by Dharma-Raksha and not any of the other known translators or groups in the test pool in the contrast corpus. My next step then was that I applied two simple mathematical formulae, which I've invented myself in collaboration with some people who know more maths, to calculate the strength of association between the individual markers and Dharma-Raksha and then between individual texts and Dharma-Raksha. I won't go into the details of the formulae today because I'd rather make a more general point. And the more general point is this. The first formula, sorry, let me just explain a little bit without going into the details. The first formula then counts an individual marker as more strongly associated with Dharma-Raksha in proportion to two factors. First of all, how frequent is the marker in the Dharma-Raksha corpus? And then secondly, how infrequent is it elsewhere? So it's basically measuring the discrepancy of frequency between Dharma-Raksha and everywhere else. The second formula considers how many such Dharma-Raksha markers appear in a text, weighted by the strength of association with Dharma-Raksha for each individual marker, and then thinks of all of this as a ratio to the overall text length so that we're not biased by small texts looking less Dharma-Raksha-like because they just have a smaller sample. That is to say, in the second measure, we are trying to look for the density of the Dharma-Raksha signal in the text. And then the final step was that I ranked all of the texts that were included in the study in the Dharma-Raksha corpus and the contrast corpus, and then a large number of other texts that weren't in either corpus because they were of uncertain nature. And that meant about 700 canonical texts in all. Generally speaking, as I hoped, known Dharma-Raksha texts came out at the top of the rankings, confirming that the measure reliably identifies Dharma-Raksha works against the products of other groups. Naturally, there were many finer complications in the interpretations of various individual results, which I won't get into now. The main overall outcome of the study is that I was able to confirm ascriptions to the Dharma-Raksha group now on the basis of much more rigorous assessment of internal phraseological evidence, and then also mount strong arguments, I believe, that a number of other ascriptions to the Dharma-Raksha group are false, and locate texts close to the Dharmaraksha group in textual history, even though the tradition did not know that they were close to Dharmaraksha. And that meant in all that I'm arguing in the final study for reascription against the traditional account of dozens of different texts. At this point then, I faced a final challenge. Once we had applied the statistical filter, thanks to the very stubborn Lee Sang-yeop, that is the log likelihood measure and Bonferroni correction I mentioned, Jamie Norrish very sensibly and logically asked, what would the outcome have been if I had skipped 3 or 4 years of human curation and just used the statistical test in the first place? That is to say, what would have happened if we worked with something closer to data instead of capta? And this is where I will just mention the juxtapositions that I mentioned earlier come back in. I call this the Norrish method because Jamie thought of it. And this Norrish method dispenses with my safeguard against the apparently nonsensical nature of such items of potential evidence. Any string that has the qualifying statistical distribution is admitted to evidence regardless of what it appears to mean to a human reader. Juxtapositions are back on the table. So Jamie and I accordingly generated a second table using this measure alone, the statistical measure alone, to select the evidence set. And then I compared the two ranking tables. And the results were really thought-provoking. In fact, I found them a little bit shocking. Generally speaking, the rankings that were based upon statistical selection alone were very similar to those that were based on my curated capta. The top of the rankings were monopolized by numerous clear Dharmaraksha ascriptions, and the test was generally very capable of distinguishing between Dharmaraksha and other things. Examining the few cases of relatively noticeable disagreement between the rankings generated by the two measures, I was honestly unable to tell for sure which of the two measures is more accurate or useful. So I was left with a situation where I think this is a problem for future research, but certainly the Norrish method seems to also be quite powerful. And this finding then had 3 main implications, I believe. First, it may well mean that juxtapositions can indeed be valid evidence for ascription, regardless of what they look like to us. I believe that there are some other arguments that also support this possibility, but this is a bit of a tangential concern for my purposes today, so I won't go further into that. Secondly, my 3 or 4 years in the salt mines, examining thousands of potential evidence in tens of thousands of contexts, may well have been a complete waste of time. Apparently, we could have skipped that step and arrived at results approximately as reliable. I mean, there were, of course, other things that I learned along the way. Sometimes I like to say that TACL has taught me how to read Chinese texts in a completely different manner. And further, if we had proceeded by this method, this was one of my concerns in the first place, we would have been working with a black box. And it would have been much more difficult to know what kind of confidence we should place in our findings. So maybe my selfless service may have done something, but I'm not sure. Third, though, and I think that this is the most exciting implication, with sufficient computing power, the Norrish method could make it possible to generalize the methods that I applied to one corpus in this study much more quickly than if we proceeded with my cyborg method, which was so time-consuming for the human cog in the machine. We could just set a machine to serially apply the algorithm that incorporates automatic statistical selection of the marker set to each major historical translation corpus in turn, and then set about a human assessment of the results of that exercise. That step 2, though, for the moment, is an agenda for future work. So that's about all I have to say about the methods and findings of my Dharmaraksha study, and I apologize that due to the limits of time, it's all necessarily so abstract and vague. If you're interested in details, I ask you please just to read the book when it appears, hopefully next year. Meanwhile, though, I want to contemplate a few questions that I think arise out of my experience relating to the shared questions that I imagine confront us in this workshop. What role might AI play in the future of Buddhist studies, and how might AI change the field? Now, you'll see in the way that I've formulated these questions that a big problem is the definition of AI. And I feel that I've been the victim of the bait and switch because since I got here yesterday, everybody's suddenly talking about large language models, and AI seems to not be the operative term, but let's just stick with what I prepared. So first of all, I think that it's relevant to sum up the work in this Dharma-Raksha study as follows. You could basically say that in both of the iterations of the test that I ran, our work developed and applied an algorithm for a computational approach to a significant research problem. We selected markers to build a significant phraseological signature of our target corpus. We calculated the weight or strength of association of the target corpus with the target corpus for individual markers and then for individual texts. Then we ranked all texts and we interpreted the rankings to make arguments and judgments about attribution. Using this work as an analogy or springboard for thinking about possible directions or applications for AI, I think it's also relevant to point out that our cyborg work incorporated several discrete units distributed between humans and machines. We, the humans, Jamie and I, designed the algorithms. Jamie wrote the code at that point in time. I don't know how he would work even if he was redoing the work now. Computers running the code implemented the parts that we thought were tractable of the algorithms for computation. And at various stages, I interpreted computational outputs depending partly on the algorithm. In the initial, more qualitative approach, I sifted through raw tackle results and made philologically grounded judgments about which strings should really count as habitual phraseology and therefore as evidence of ascription. For both approaches, I still had to grapple at the last step with the rankings and try and figure out what arguments I should make to ascertain their meaning for ascription. This is, of course, especially difficult in the grey areas on the edge of a corpus. So one thing we might try to do then is to imagine how all of this could be changed by conjectural future development and wider implementation of AI. And I would like to suggest that this line of thought at least raises several questions, at least for a kind of yokel from the humanities who's wandered in like me. I'm worried that the computer scientists will find this all painfully naive and simplistic. But it first then seems to me that if here today on behalf of Buddhist studies we are contemplating the consequences of the leap to AI, we are more or less leapfrogging a possible phase of development, a bit like populations in the developing world who are leaping directly to smartphones and the internet without having passed through the stage of landlines or older broadcast media. We have had a digitized Chinese canon for 30 years. At Christmas, some of us will attend celebrations of this landmark event in Tokyo. And yet one of the things that strikes me about my Dharma-Raksha work is how rarely to date other work in the field has applied the leverage afforded by computation to actually solve problems. We have had our fair share, I think, in Buddhist studies of standard issue digital humanities, which I take to mean something like new modes for digital presentation, preservation, organization, correlation, and even discovery by search of quite vast bodies of information. And I don't want to poo-poo the power and value of such work and the transformation that it has wrought in the field. But I can think of relatively little other work that has, apart from actually some things that Marcos has done, that has attempted to solve through what we might broadly describe as algorithms and computation, outstanding research problems in the field, discover new, hitherto invisible patterns in our record. It seems to me that this may well represent a missed opportunity. Even without revolutions in our technology, even with old-fashioned tools and computational power that's already long been at our disposal, I suspect that there are probably other problems on which advances could be achieved by a more creative and proactive application of the power of computation. So with a little poetic license, we might even venture another analogy. In thinking about what AI, so-called, might mean for Buddhist studies, we might be like a rusticated population that has had the wheel for quite some time, but mainly used it to throw pots. And we're suddenly trying to think what it might be like if we had personalized flying cars or even anti-gravity or faster-than-light technology. By this I mean to suggest that we're not only leapfrogging imaginable intermediate stages, but possibly we also don't even have a very clear picture of what we mean by AI, or what it might mean, and we don't know when or if it will really eventuate. Sebastian has already touched upon this. It seems hard to clearly discern the dividing line between realistic expectations and science fiction and marketing hype. So as an interested layperson who reads newspapers and blogs and things, in the commentary that I read, futurologically tinted speculation about the implications of AI tends to focus on something like a generic general artificial intelligence which could flexibly match human performance across a wide range of capabilities, or even some kind of superintelligence that will outperform us and discover new dimensions of performance that we cannot anticipate. And so we might think, what's Buddhist studies going to look like if that comes along? I'm not even sure that that's a question that we should be considering, but perhaps that should be a topic on the table for us for these 2 days. I personally can't think of any way to think effectively about such uncertain prospects if they can only be visualized in such vague terms. And I therefore think, and this is where Sebastian has actually already kind of stolen my thunder, that it might be better to think concretely about the likely impact of more concrete technologies that are already in existence or visibly in the pipeline, like automated translation or rapid, virtually instantaneous alignment of vast quantities of text, or even something like the rapid but still bullshit-prone and quality-blind aggregation of the total contents of the hive mind, which is afforded by tools like ChatGPT. But that might mean then, I think, that AI is something like a misnomer for the purposes of a discussion like this, and that for the time being it might be better to set aside that more generic possibility and think about more specific demonstrated tools. So with these provisos in mind, it seems to me that the lessons of my Wild West-style adventure in computation might be better formulated as questions rather than anything like predictions or speculations. One very basic feature of my work with Jamie Norrish, which both of us have thought about a lot and we talked about a lot as we worked, was our collaboration. At one point, just to give an example, I tried to learn Python myself, and the results were frankly humiliating. I have rarely in my adult life felt so stupid, except when my wife's friends decided that it would be funny to give her tango lessons for her 50th birthday, and I had to go. I mean, I could really barely imagine to write the simplest code, and I've kept forgetting the simplest lessons. So through all of these years, I kept daydreaming that it would be amazing if I could one day maybe reach a point where I could do something like Jamie, who could whip up code on the fly just to try out a hunch about what this or that might work. An ideal combination of Buddhology and coding in one brain, which is what I think of as doing a Sebastian Nerdisch. That daydream may now be rendered, well, first of all, it's now been rendered much more poignant, unfortunately, by the fact that Jamie prematurely passed away earlier this year. And so I no longer have my collaborator. And that also then lends much greater urgency to this question of how we might find resources that enable us as humanists to monkey around with this. But one question that I ask is whether future Buddhologists might be able to use the power that I hear about for coding, for ChatGPT and large language models to produce rough code. So we might all be able to learn to code much easier. And that might mean that then this daydream of being somebody who can actually code some stuff on the fly lies much more closer than if we're all as stupid with Python as I was. Secondly then, I also find myself prompted to ask whether we have any reason to anticipate that computer tools of some sort might one day be our partners in designing the algorithms, because this was another part of my collaboration with Jamie. I said at the outset that I don't think that my methods counted as artificial intelligence in light of the years that I spent slugging away like a dumb ox, especially on the evaluation of possible evidence. I'm not even sure that my methods counted as any kind of intelligence. But setting aside my Kiwi self-deprecation for a moment, I do in all honesty think that my overall approach was not totally stupid, otherwise I would have done something else instead. And this prompts me to think how difficult it might be for us to reach a point where we would actually be expecting computers to help us design our studies or arrive at our hypotheses or figure out creative new ways of coming to grips with standing research questions. As far as I'm aware from my limited reading, present-day so-called AIs are at the very earliest stages even of so-called problem solving. And the idea that they could be really creative or participate with us as partners in truly original research is surely a pipe dream. So that's just a way of saying intuitively how far away I think we are from something like the general AI models that we read about. And a final element in the larger algorithm that shaped our Dharma-Raksha work together overall was the interpretation of results and the construction and assessment of arguments. I suppose that if we ever arrive at a true general artificial intelligence, we would also expect it to join us as a partner in that endeavour. But once again, so far as I'm aware, the evaluation of arguments or their relationship to evidence, which seems like it's a much simpler matter, is still well beyond the capacity of any tools that are presently presented as so-called AI. And so is the judgment between multiple alternate claims or competing possibilities, or even, in some cases, identification of basic factual errors. So in that respect, I suspect that our methods are fated to remain cyborg for some time to come. If that's right, then, I expect that the limits of general AI, in the sense that we read so much hype about in the media, are rather quite close for application in Buddhist studies or in our subfields. And it may sound as though, by talking about things like invention, argument, or judgment, I'm setting a very high bar for the precipitation of real sea change in our field. But I don't think that that's necessarily quite so highfalutin as it sounds. I do think that philology, this is a sidebar and a kind of a hobby horse, I do think that philology itself is absolutely fundamental to much of the fancier work that's done in our field, since obscure and difficult texts still comprise such a significant chunk of our evidence base. And I think that one reasonable definition of philology is that it's the discipline and skill set that we apply to read texts when we need basic, fresh research just to determine what the text says and what that means. That means that the very establishment and interpretation of our fundamental evidence base already takes us beyond the horizon often of what is collectively known, or documented by reference books or everything that is sedimented in the cloud. And I think that that's a good indication that this kind of creativity that I'm talking about is already required even for what we think of as relatively basic spadework in the field. And therefore that, by contrast to that standard, we're likely to be thinking far more of more specific tools that leverage our abilities in particular domains, as Sebastian was talking about previously, rather than a new set of computational collaborators who are suddenly going to be working alongside us as some kind of partner. So that might mean then that the main fruits of my more speculative flights of fancy, thinking this question through, are negative, telling us less about what so-called AI might be able to do for us than what it cannot yet do, and what hurdles we might need to clear before we start speaking of intelligence in any meaningful sense of the word. But even if that's so, I think that it might also be useful as a way of spurring us to characterize and speak more precisely about the emerging toolkits that we can work with, or soon will be able to, and also perhaps to assuage more general fears that we or our students are in imminent danger of redundancy and complete replacement. So I think that instead it might be more realistic to expect that the balance between human work and the work of the machine is likely to shift considerably. So we might have a change in the division of labour between the partners in the cyborg collaboration. I personally think that if we in Buddhist studies can outsource some of our work, especially the donkey work that we do, to reliable machines, that might be a huge blessing, especially because our field is so vastly underpopulated and under-resourced in proportion to the vast mass of still untapped evidence and sources that we have to come to grips with. And in that sense, I suspect that we're really only facing an analogy to the equipment of the natural sciences historically, and their experience with instrumentation which magnified human faculties and extended their reach, rather than supplanting them altogether. So we're thinking of equivalents perhaps to things like telescopes, microscopes, calculators, accelerators, spectrometers, and all the rest of it. And I cannot see why then, in the field of Buddhist studies, we would not welcome as quickly as they can be invented such helpmates like automatic aligners, automatic translators, even if they're rough and fallible at a first pass, concordance makers, or more sophisticated quasi-semantic search engines, all of the wonderful things that Sebastian just trotted out. To resist devices like these, it seems to me, would be as if an astronomer in the 17th century said, I like doing my observations with the naked eye, and I'm not going to have anything to do with these newfangled telescopes. Thanks very much for your attention. I look forward to the discussion.
I'd like to make one comment about the bait and switch. We've been saying for 30 years that as soon as AI works, we call it something else. So that's responsible, I think, for the focus on large language models. So, yeah, Sebastian.
Thank you very much, Michael, for your great presentation. And I mean, about the what we call AI and your speculations on philology, we have hopefully a lot of time to talk about that in the coming days. But to come back to your main presentation, the statistical comparison, I think that is super interesting, and I'm very happy that you made this comparison against the non-human filtered approach versus the human filtered approach. And there's one bitter lesson that we had learned in our Vedic text dating project that we had in Germany before I came to Berkeley, and that is at some point we figured out that our human priors that we put into the Bayesian modeling of the statistical models are actually the biggest determinants of our outcome. So whatever we feel is important, our system is going to put into the model to such a degree that it determines what comes out. So the whole idea of dating Vedic text with Bayesian modeling came more and more questionable the more time we spent on doing it, because we figured out that maybe that's just not the right approach. Maybe we should reduce the human bias as far as possible. So if I think about this idea of human selection on the futures, I would even make the controversial claim, and I know it's maybe not nice to say, okay, your work was even less valuable than the manual work of providing all of these annotations of the individual parts, but I would say it's even fair to make the argument that this could actually hurt the performance of the outcome, because we are introducing human bias to an observation that ideally should not have any human bias. So that's just a note, but I think you presented it, I think it's very clear.
Yeah, thanks for the comment. If I can just respond. This raises, I mean, you're completely right, and this raises two issues, I think. The first one is that one thing that I omitted for the sake of simplification is a first step that preceded all of the algorithm that you see on the slide. I had to decide what was going to be in my reference corpora in the first place. And that was another very large job, one that required lots of dubious judgments. And the approach that I took was hyper-conservative again, compared to standards that are normally applied in the field. But I nonetheless still had to have a bootstrap corpus that I used to define, as the golden standard, to define attributions to each case. And Jamie always used to say, this is nonsense. What we really need is some kind of, we've got to start from zero. So he loved this idea of coming up with a bootstrap algorithm. And we had many conversations over the years between us, but also with numerous other people that said that just a general application of pattern recognition might be far more promising and certainly more objective. One of the limitations then was our own technical expertise and the resources that we had, which were, I mean, even in computational terms, but certainly in terms of human time, very limited. The second concern it raises, so what I want to say is that there's another feedback loop which then builds in centuries and centuries of human biases into the results, and my results are even more dubious and less valuable than you suggested. The second thing, though, is that there was a strategic concern that I had in mind, and that is attempting to sell any work like this to my humanist colleagues, to my philological colleagues. Yeah. And so the motivation at the moment when I made my fateful decision to qualitatively curate the evidence was that I wanted to make sure that the evidence set was not in a black box, that it could be opened and seen so that people knew what I was working with, and that it hopefully looked at least close enough to the sorts of things that the tradition of scholarship in my subfield has recognized as evidence, that people would not say, come on, this is just nonsense. And so I was thinking of my work as a kind of expedient means and intermediate step along the way to eventual acceptance of more automated or perhaps quantitative methods. And the idea, particularly with that comparison, was to try and show that the results that emerge are, first of all, quite respectable or quite plausible against what we would have been led to expect by what we knew in the state of scholarship previously. And secondly, that the more automated methods produce results very much like an extremely rigorous philological model that has human judgment built into its core. So that there, I mean, in a way, there's a designed obsolescence. I was imagining that I was producing a piece of work, and ideally it will be superseded very fast, but hopefully it will serve as a useful step in the direction of something else.
Yes, thank you very much. I have a question about the variants, because we know that the Cathal came and made a lot of editorial changes. A lot of those are reproduced, and then the manuscript tradition continues with the original forms, and then we have competing canons with different forms. Were you able to incorporate the variants into your database?
Yes and no. Yes, in the sense that we spent a lot of time again at one point making sure that we basically build a database of all of the n-grams in the canon, so we're not reading the text directly at the moment of computation. We're actually working with a kind of a compilation of all the n-grams already. At that point, we were at least able to incorporate all of the variants that are recorded in the Taisho apparatus. But those of you who are familiar with textual history know that that's actually an inadequate subset of the full range of witnesses that we have, and often in many cases not the most interesting set of witnesses that we might need to work with. So even to the extent that we were doing that, it was a half-assed, unsatisfactory job. The second thing is that methodologically speaking, we would, even if we were to have some perfect way of using all of the witnesses that have been transmitted to us historically, we know that that's an imperfect picture, and it's quite likely that there's been a certain amount of corruption that we simply can't undo or fix. And so we're never going to get back to a pristine situation in which we can see the texts as they were originally produced by the brush of the Bissau in the workshop on the day in 292. And so the methods have to be foolproofed against that possible confound to some extent. And I think that they are by the sheer quantity of the evidence that we're working with. This has, I think, an analogy to what Sebastian mentioned when he was questioned about possible inaccuracies in some of the training data in parallel translation corpora, is that you don't get 100% accuracy, but if your arguments and your judgments are built on a very, very large number of pieces of evidence and data points, the likelihood that it's all pointing in the wrong direction is very, very small. And if your data outnumbers the likely quantity of variance that was originally in the signal, then you still have relatively reliable results, even though you haven't cleaned the record completely in the meantime, I think.
Okay, time for one more? Yeah.
Thank you, Michael, for the wonderful presentation. Maybe it's going to be a question to both Sebastian and you yourself. We talked a little bit about that, Professor Kirk, but do you think that a layer of metadata would be interesting, in conjunction with LLM, so that it would maybe reduce the black box effect in a way, while, reaching conclusions that would be facilitated by the LLM and the whole environment, and so many things we can do together with just having statistical results. But like coupling the two.
Do you want to give some examples of what you're thinking of for metadata?
Yeah, I'm thinking, for example, any kind of like corpus linguistic stuff, collocational, like stats, or corpus-based, patterns that would be identified with, say, Python scripts, basically like the old way of doing things, running, the algorithms, on the corpus. So, and then integrating this somewhere in the model, having capacity to access the two worlds, right? The world of static data in a way, and then anything the element could bring. How do you see that?
I think my answer to that would be that precisely good metadata is what makes all of these interesting observations possible. We have annotations where we can compare different sections of a corpus against each other, because if that is not available, then we are basically just stealing a huge pile of data. And I mean, that's doable and results come out, but the more hard annotations we have that have a high standard, the more interesting observations we are able to make. And this part of metadata, the collection, the curation and so on, is like one of the biggest challenges for a project like ours, is to have the right type of data, and that really then also makes it possible to, every metadata again is in a way also imperfect. That's the other problem. As soon as we do this, then we end up with the questions that Michael is raising here, like how reliable are attributions, what can we do if we look at the actual data. So, but this is in a way, I think this work is extremely important, but it is also making the work of metadata collection even more difficult, because it questions what we already have handed down via traditions and so on, but it's, of course, extremely important. So if I can comment just briefly, I think
I have nowhere near Sebastian's technical knowledge, and I'm not even sure I can adequately imagine all of the different possibilities for what might count as metadata for the purpose of your question. But we certainly face an extremely large logistical problem. So we're talking here, I think, about something in the neighborhood of 230 million Chinese characters when we're dealing with the whole canon. And I do not know how long it's going to be before we have an annotated corpus. Even with the exciting developments in automated annotation and markup, there's going to need to be a phase of human check, and just human checking is already possibly something that will be expensive and require decades of work. In the meantime, we do have a huge steaming pile of raw data, and one of the perverse or kind of ironic things about the way that this study ended up being shaped is that, first of all, to give an indication of how little metadata we have, I believe, at least at the moment when we were designing these studies, there was still no reliable way of separating words in classical Chinese. And I think that task has not yet been solved. So we don't have automated word separation. We're not finding class or parts of speech. We don't even know where the word begins or ends. Yeah. And so we were forced to find a way that did deal with the text as just raw strings. And in a sense, that pushed us in the direction of this extreme conceptual simplicity that I was talking about. And I think that in the end, was serendipitous. It allowed us to discover an extremely conceptually simple method that appears to have worked. But that is just an indication of how far away we are from a kind of utopia in which we might be working with metadata for a corpus of this size, I think.
Thank you very much. Let's thank the speaker.
Thank you.
Our next speaker is Jan Rodas from the Buddhist Digital Resource Center. He's the executive director there. And I did just want to chime in that we talk all the time about models, but if you insofar as I understand these models and you kind of look under the hood, so to speak, the engines look a lot the same. It's what you put into them. It's the mixture of gasoline that's really making the difference. And that, of course, that doesn't play as well in the West as talking about your model. And so in our own work, the contribution of the Buddhist Digital Resource Center and Jan's team has been so critical.
Thank you, Kurt, for that introduction. I was going to begin by saying that this talk is going to glorify the intermediate steps. What I'll be presenting on is the donkey work and how AI, and by that I don't mean LLMs per se, but more like computer vision and deep learning, have helped speed up and make more accurate the intermediate steps so that we all have more data to work on. So how do we get our data? Where does it come from? That is sort of the sub-theme of the talk. So using AI to transform BDRC's massive archive of scans into a data set for research and AI models. I'll be speaking for about 10 minutes to give the introduction, and then I'll be joined by my two colleagues, Ellie Ru, the Chief Technology Officer of Buddhist Digital Resource Center, and a colleague of ours, Eric Werner from Hamburg. So it's probably, a good time at this point in the afternoon to do a little show and tell, a little storytelling. So the founder of Buddhist Digital Resource Center was E. Gene Smith. Again, it's good to understand sort of the human component of where these texts come from and how they came to be. In thinking about this work, it really goes back 60 years. BDRC is currently celebrating its 25th anniversary, but the work goes back many decades. Gene worked at the Library of Congress in New Delhi from 1968 to 85, although he first moved to India in 1965, so about 60 years now. He was a leading early scholar of Tibetology in North America and the West more broadly, and a huge supporter of the cultural preservation efforts of Tibetan refugees. So PL 480 will be a sort of leitmotif of this talk. Gene was able to preserve in the sense of manually reproducing in paper and ink copies thousands of volumes of Tibetan texts, because through the Library of Congress he was able to access funds from the State Department to do this work. And the funding mechanism was Public Law 480, PL 480. Many of us in Tibetan studies know those works. Over 8,000 Tibetan volumes were saved and reprinted. They came from all over. We typically think of these volumes as having been carried on the backs of Tibetans over the Himalayas when they were fleeing Tibet, beginning in 1959. That's true to some degree, but actually, because numerically not that many texts were brought over, and Jean wanted to create a sort of very comprehensive and diverse collection of Tibetan texts, he sought out volumes representing all the different traditions and different fields of knowledge from Ladakh, Sikkim, Darjeeling, Bhutan, and elsewhere. And so the volumes that were reproduced were sent to major research libraries in the United States through the Library of Congress, but because of an interesting deal he made with the printers, dozens of copies of each text that was reprinted were distributed at very low cost to libraries and reestablished monasteries throughout South Asia, which really helped with the revival of Tibetan Buddhism in India, Nepal, and Bhutan in the second half of the 20th century. So PL 480. The reprinting of the texts represent PL 480 1.0. Jean retired in the mid-90s, and from the Library of Congress. After Delhi, he went to Jakarta, where he was station chief there, and then to Cairo. At the invitation of the Trace Foundation, founded by Andrea Soros, and with the support and encouragement of Eric Collenbell as well, Jean was brought to New York to do a PL 480 2.0. That is to take his paper and ink library and digitally reproduce it using prosumer grade scanners to create a comprehensive database, and then to make the database available online. This is how the work proceeded. This is what I mean by the intermediate steps that just have to be done by hand. Many of us remember that. So just as Jean tried to serve both the scholars and the tradition through the broad dissemination of a massive, very comprehensive, well-curated library of Buddhist texts, through his PL 480 2.0 work, he tried to make these more widely available through electronic means. First via CD, and then once everybody had better broadband, then through the website itself. TBRC, the original organization, then expanded its mission in 2015, changed its name to Buddhist Digital Resource Center, which we're still called. Since then, we have embraced this new expanded mission and begun working in other areas where we feel that there's a need for an intervention like this. Our first big project after we expanded our mission was with the Fragile Palm Leaves Archive, compiled by Peter Skilling and located in Bangkok. The project at the Fragile Palm Leaves Archive is ongoing. I think we've digitized about 80% of Peter Skilling's 11,000 bundles of Burmese palm leaf manuscripts, and we'll finish in about 2 years. So talk about intermediate steps. Each page needs to be cleaned, re-inked, and then digitized by hand. I think there you see how it's done. We also did a project during the pandemic on the ground in Cambodia with Khmer manuscripts. And this was the brainchild of Trent Walker, our Berkeley colleague. And this was also hugely impactful. We estimate that through this 3-year Khmer manuscript digitization project, that we were able to access and capture about 85% of the known extant manuscripts in Cambodia. And the largest collection that we were unable to access are fairly well preserved because they're at the National Library, the Silver Pagoda, and the National Museum. We thought we could, just go into Phnom Penh, work with those major institutions, digitize hundreds of thousands of pages, feel good about ourselves, and leave. But none of them wanted to work with us. And so we had to get a Jeep and start going out into the countryside. And so the work ended up being, much more fulfilling, much more impactful than we could have ever imagined. All thanks to Trent Walker and his great connections, and of course the staff on the ground. So we feel that the final count is that we digitized about 700,000 individual pages of palm leaf manuscripts that we accessed at libraries and temples, and then another 500,000 folia that were filmed by the French, the FEMC. And many of the manuscripts filmed by the French are no longer extant. They've been lost. And then there is some overlap, which is good because it's better to have the full color manuscripts. And all of those are already online. Another very exciting project that's still underway is a digitization project of the National Library of Mongolia. And this is done in partnership with Asian Legacy Library, ALL, based in Sedona. They are the ones who did the very crucial diplomatic work to get access to the National Library of Mongolia. The buy-in and participation of the administration there has been really crucial. They do tremendous fundraising and management to make sure that this project is highly productive, and BDRC offers a lot of its services in terms of training and troubleshooting. And then, of course, we're the repository for the scans and the main access point through our website. To give you an idea of the sort of before and after of this project, the National Library of Mongolia's Tibetan collection is estimated to have about 35,000 volumes of Tibetan texts. And when we begun this work in about 2017, 2018, thousands and thousands of the volumes were still in the original state that they were in when they were gathered up by the Russians and deposited in this warehouse in Ulaanbaatar. Unorganized, mold problems, and then simply inaccessible to Buddhist scholars, monks, and so forth. So the work has not only digitized things, but done, even more preliminary steps, like just open things up, shake out the dust, figure out what's what, try to recombine collections and so forth. It's really a gift to Mongolia. So as you can see, there's a lot of image data that's being produced. And when we were still in PL 480 2.0 land, that was the state of the art. Wow, earlier we would have to go to the library, in the case of UVA, get the librarian to go and fetch the key, take us to the Tibetan cage, borrow a book. They're usually enormous, too big for copy machines, kind of a hassle. Now we've got texts on CD, we can look at them on our computer, fantastic. And for years we thought that was the most convenient and the most we could ask for. But now, thanks to AI, we've entered PL 480 3.0 land. So what my colleagues will introduce and demo for you today are these critical recent interventions that we've made that have allowed us to take these static scans that contain within them so much knowledge and information and wisdom, and to extract and make usable metadata and content, which is useful for the BDRC database, but also, of course, for many other research needs. So I wanted to start there with just showing you this massive amount of data that we generate and make freely available online. That's been good enough for a long time, but BDRC has been keeping up with the AI revolution, largely through collaborations. And so we're going to talk now about computer vision and deep learning that have allowed us to process images, which in the past was very boring grunt work, automatically generate metadata, which takes experts and a lot of time, and then beyond that, OCR, to extract the writing in the text and format them in ways that make them usable for a variety of research needs and for cultural preservation as well. So I'll just leave you with a couple of numbers. BDRC now has over 30 million pages of texts of digital images in its archive. 25 million of those are in the Tibetan language, and 5 million, more or less 5 million represent Southeast Asian texts in Burmese and Khmer. We also have some Sanskrit and Chinese, 30 million. A tremendous amount, and it's now going to be even more accessible to all of us. All right, PL 483 3.0. So I want to hand this over to BDRC's Chief Technology Officer, Ellie Rue, who has created so many of the tools and so much of the data that you all find to be really on the cutting edge of Buddhist studies.
Thank you. Good afternoon, everyone. So yeah, the title of this section is AI to Unlock the Archive, which may seem a bit strange because the archive is online in open access. So what's there to unlock? So I think the first thing is that the world changed. You know, as Jan said, just having scans online is not necessarily what users want now, users need. And also the scale of the data is not the same. In the sense, if I give you a hard drive with 100 Tibetan images, chances are that you're going to just browse through it and find some interesting data. If I give a hard drive with 30 million Tibetan images, chances are that you're going to be a bit lost and the hard drive is just going to be on the shelf taking the dust. So from this point of view, even if it's totally open access and online, it's still only partially accessible. And I think we have this responsibility, I would say, as caretakers of this very special collection, to make it really fully accessible to the widest audience possible. And I think the two main aspects that are required are metadata and also transcriptions, for search, etc. And it may appear that most of the metadata is already there. I mean, we have at least one title per collection. But in my own, perhaps pessimistic estimates, I would say that we have only half of the catalog of the Tibetan collection. And in this half catalog, there's probably only half that's really complete with links to the authors, etc. This is, I think, due to the sheer scale of data, of images that we received over the years. That's our limited resources didn't allow us to fully catalog. So I think we feel the need to really complete this catalog, have the good transcriptions, etc. But unfortunately, it's kind of a boring project, not really in the sense that people involved are bored or feel depressed or something like that, but it's a little bit hard to sell, let's say. On the other hand, what's not hard to sell is AI. So how what's the, I don't know, the place or the role of BDRC in that new environment where there's a lot of energy, a lot of research, a lot of experiments that are made in this new technology, and also a lot of resources. So I think I was really happy that Sebastian answered the question just before and gave this answer about the importance of metadata, because if we want, let's say, all of the BDRC data to be usable by AI, one requirement will be proper metadata, proper transcriptions, etc. And so in order to fully make the archive accessible also through AI, which will help, I think what we want to to explore is kind of a feedback loop between the needs of AI and also the possibility that AI offers to expand the metadata semi-automatically. So yeah, there is this sort of convergence between our needs or our users' needs and what AI needs, which is, I think, very fortunate for us. So I'm going to talk maybe first about two small experiments, or I mean small experiments, very successful projects actually that are finished and that don't really deal with like all the incredible stuff that LLMs can do, etc., but more focusing on small AI projects that we use to improve our data. So the first one has to do with the National Library of Mongolia that Jan presented. So in the original import that we made, we had one title per volume. But it happens that on average, there's about 10 texts per volume. And sometimes they are completely different. There's like one xylograph, one manuscript, another completely different manuscript, etc. So having just one title by bundle is clearly not enough to make this collection discoverable and understandable. But unfortunately, the catalog that is produced by the National Library of Mongolia didn't have the image numbers for each text. We didn't know which image the text started, ended, etc. And the catalog is about 110,000 texts, so it's a little bit too much to do by hand. Fortunately, the NLM also puts a stamp on each page that where a new text starts. So our idea that Eric actually implemented was to train a small model to recognize the images where a stamp was. And after just a few iterations, like making a little bit of a small data set to train the model, it worked perfectly fine, more than 99% accurate. Sorry. And so the result of that is that after a little bit of manual work to account for the discrepancies in the catalog, in the stamps, etc., we were able to import 110,000 new entries in our catalog, which seems like a lot, and it is a lot, but it's unfortunately just the tip of the iceberg of what we need. Another successful project that we are proud of, let's say, is this web interface. So we had a backlog of about 2 to 3 million images that were in that format. So one image where 2 pages were, and what we usually do with that kind of image is to cut each page and have it in its own separate image. Unfortunately, doing that for 3 million images by hand, as you can imagine, is a little bit tedious. But we thought, well, why not try SAM, the Segment Anything model from Meta, to detect all the pages in the image. And actually it works really well. It still requires a little bit of human intervention when it misses or detects some hallucinations, etc. So we built this very simple web interface where the work can be reviewed. And yeah, that allowed us to segment 2.5 million images with 1.5 million images to come. So this is, again, working at a scale that really requires that kind of AI tool. So this is the type of feedback loop that will be more and more present. And finally, in terms of the transcriptions, like OCR, etc. So Eric will talk about like more technical things that we did. But I'm just going to introduce first a quick history of the transcriptions, because it's always been an intuition of BDRC that the transcriptions would completely transform the way the data can be accessed and used. And so as early as 2015, with the NAMCell OCR project that Kurt participated in, I think OCR'd about 1 million images, so mostly modern publications. In 2020, we started to work with the Google OCR through the Google Vision API. We OCR'd about 3 million pages. Some of them have been reviewed in the Norbu Ketaka project. Then we are using now Google Books, etc. So we arrive at a total of 5 million pages, with about 2 more million pages that can be easily OCR because they are also modern publications. So this is a really great achievement. But again, unfortunately, it's just the tip of the iceberg because there's 20 more million images to OCR that we don't have the technology to transcribe yet. So among these 25 more million images in total, 20 million images in Tibetan, and among these images in Tibetan, there's really a great variety of different scripts. So that may anticipate a question. And so for the needs of a project, like to start a project to OCR all these different scripts, the first step that was asked to start to train a model, etc., was to have a small data set where all the scripts would be represented. So we thought, well, that's very easy. We just take a good list of scripts, and we select some images for each script. Unfortunately, there is no good list of scripts, surprisingly. So we worked with a graduate student called Pensok Mongiel on this new list of scripts that we can use to create this model. And this is something that will be published, we hope, in April or May next year in a journal. So this is just to give you a little overview of what it looks like. So this is just the taxonomy for Ume, but as you can see, there's really a lot of them. There's a document with like a few examples, which looks like this. Okay, so that was like the first step, for this new OCR project. And it's interesting to see that the needs of AI led us to do a project that, at the beginning at least, can be published without any kind of technology or AI. It's just like pure paleography. So now I'm going to let Eric present the technical parts.
Thank you. Good afternoon, everybody, also from my side. We did quite a lot of things over the last couple of months, and the chronology was a little different. So we started with OCR and script classification, as we see drafted here, came in like a couple of weeks ago. So we basically just tipped our toes into that area, and we did some very rough experiments where we basically just tile every input image and run different fine-tuning mechanisms using different architectures to see if we can get anything out of it, and something that works. And just to get you an idea, this is just an image for you to get an idea how things are done on a high level. So we feed each tile to a model and get a prediction per tile, and then we just take the most common one for the page level prediction. And I did some experiments on the line level, which we have to exploit a little further, since you have a lot of materials where script changes within a line. So we have to think about more fine-grained approaches in the future. And connected to this image and this overview, you can see here a preview of a data set created by Pensok Mongiel, the graduate student. Where you can see these are the 30 classes we using by now, as of now. Whether we need all of them in an OCR pipeline remains to be seen, because a lot of the scripts are very, very close to each other, and we expect that the OCR networks will be able to cope with very close scripts pretty well. For instance, everything probably that's written in Ume, the first 1.5 lines can be possibly just taken together. but just for you to see what we're experimenting with at the moment. And yeah, OCR is actually the project I was heavily involved in over the last couple of months. So from a general problem statement, as Jan mentioned, still a large part, despite of various projects of transcribing or typing texts in the past and publishing them in modern form, a lot of text is just like kind of hidden in images and not available for full text search, something that anybody interested in philological questions, historical research, philosophical research is interested in, like tracing quotes, finding parallel passages, etc. Something I did in the past by myself. So, so these things, from a practical point of view, just take a lot of time. And OCR is one of the very basic things that just need to be done, and the time is just right. And there are a lot of challenges involved. So, as you could see already here, materials are very diverse. Sometimes the pages are bent, incomplete. So it's rather challenging from that perspective. And we look for at least a solution that comes or balances out the cost of using it, because a lot of the recent models are very expensive to run or can't be run on consumer hardware. And the idea was also to build something that is just available and not, you don't need any kind of cloud services or so to run it. And being involved in an OCR project in a university context in the past, I made the experience so often nothing really usable comes out of it, and thankfully BDRC we came to agreement that building something that really just get this problem solved is a very good idea. And so one of the first steps for OCR is, of course, finding the lines in any given image. The preview of what you can see here. So we do line-based OCR that might change in the future, but at the moment we build the whole pipeline on more or less very well-established technologies. So line-based OCR was maybe up until a year ago or so, where the first just page-based document understanding techniques came up, just the way to go. And it works reasonably well, and it's fast. So the approach taken for identifying the lines is, technically speaking, image segmentation. So we get a per pixel classification of what is a line or what is not a line. And we use DeepLab v3 as the backbone model for doing that. So, and there are a couple of steps involved. So as you can see up there, this page there is slightly bent. That might cause issues down the road. So we devark a page if necessary. As you can see here, this page up there is even worse, and it will harm the OCR output really badly. So we have to find a solution to at least straighten the line as much as possible. And of course, then enumerating the lines, sorting them, because within such a pipeline, the natural reading order is lost to a certain degree, so you have to reconstruct this. And you can see here the blue circles, for instance, indicate the line breaks, and you see just the line numbers like running from 1 to, this is 19. And so we do line detection. We also have like a little bit more multi-class segmentation model, as you can see here. So this model can detect what is an image or what is a caption. We are experimenting with this. It works well on a lot of materials, but of course you will always, within this 25 million pages or so, find a few cases where things just still break apart. And yeah, that's the current data. everything is trained on. Again, we do image segmentation on square tiles. And when the data, I don't have the number now correctly, but they're generated with an 8% overlap and resulting in this kind of training data sets we are using as of now. So there you can see an image with in the background is the original image and the mask, so to say, where we have what the model should learn, what is the core of the line. It's just highlighted there. Yeah, and then we moved on and trained from the extracted lines, as you can see here down, OCR models. And we did this with CRNN and Easter2, which are two CNN-based networks, which are very fast to train, which allows like small iteration. You can run a lot of experiments in a very short time, which gives you valuable feedback. TRLCR is a more modern architecture, but it consumes a lot of computational resources, takes really a long time to train for let's say whatever we have, like almost like 4 million images for Ocean. So things just take longer, and also the inference times are much higher, and it's very hard to, or almost impossible to run on consumer hardware, just on your laptop you carry around with you. And we're experimenting with different like tokenizers, so Wiley character-based or Tibetan Unicode stack-based, where we just split things into individual syllable parts. We are experimenting with this and see each model has its advantages and disadvantages. So there's a lot of like work in progress. And right, we train, for instance, just models on woodblock data only, and also on modern type set data only, and mix them, and then we run evaluations on the same test set and see which model has problems with which samples and where are the errors, and it gives insights how to move on. And yeah, thankfully to OpenPager, of course, we got a lot of curated data sets where we had a base to work upon. That this was really data that was reviewed by humans. So that's often the most time-consuming and hard part in such a process, getting enough like good data. Yeah, of course. And now we're looking at real-world performance, just downloading some images from the archive and see how good these models we have now actually work. And the challenge is, of course, to evaluate these models on unseen data and automatize this process. We cannot like hire 100 people looking at OCR output. That's not a feasible situation. Yeah, again here a more fine-grained overview of the data sets we're using. So as Ellie mentioned, there was this Google Books data set that was being reviewed by OpenPager, Nobukitaka data. These are modern typeset data sets. And then we took a couple of woodblock data that is currently the core of the woodblock model. And this, I call it CameraPy 8. It's a data set with some thousand lines from various like woodblock data images as well. And we also started training models for manuscripts. So there are a couple of million UMI manuscripts, and most of them are just not available, or also just available for experts who can read UMI. And there's a high interest in OCRing these materials because often they are very old, like 11th, 12th century materials, often not studied due to the fact that they're hard to read, so you have to learn these scripts first. Again, here are some line examples that are the inputs for the OCR training. And as I mentioned in the beginning, the idea is really to build a pipeline that is usable also just by researchers, and not using any artificial or introducing artificial barriers that you have to log in somewhere, upload your data. You probably, in some situations, can't even upload because they are copyrighted or sensitive for one reason or another. And so the current idea is, apart from scanning OCRing the entire archive on the back end from BDRC's side to make the e-text available, also to build a desktop application that's cross-platform and easy to use, so that you can just use OCR on your own without intervention. And as you can see here, it will be cross-platform. It will run on Windows, on Macs, and Linux systems. It's written currently completely in Python, since some of the libraries for language processing are currently written in Python, and we need just a quick transfer from experimentation code to application code, so to say, without having to rewrite the whole thing in another language, even though it might have advantages, but that's something for the future. And yeah, we hope to release a public beta before the end of the year. And that's how the current application looks like. Yeah, here blank and here load with data, so you can just scroll through your imported images. You get a preview like Canvas where you can see the image and then run OCR and you get the lines out there. And you can export it in various formats, like here, pick a model of your choice or what you regard as the best at the moment. We will very likely add the script classifier into the whole thing, so to suggest a model. But of course, you can always then pick and choose, or see if you figure out, okay, this model seems to work better than the other. It just shows another one, and then just run the whole thing and export the files to your disk. And maybe we can have a brief demonstration. Let me see.
We're going to demo it live now and hope to release it before the end of the year.
Yeah, let's hope it works, that it won't crash. Let's see. There's always a certain risk involved doing that live. Yeah, live demos are dangerous. Let's see. Now we got to bring a mouse, so fingers are a little jittering. Okay. Whoa. Okay. Okay. Just let it run. Okay. There you go. Okay. Line preview. All my fingers are nervous. Okay. Hide the line preview. And switch it on and off, and there you get your text. And then export a text file and use search or on your own computer, or yeah, the idea is really to OCR the entire archive in the near future and build.
So it's a page at a time, or
you can go like page by page if you like, but of course you all have this batch processing.
Okay.
So pick a model, pick an output format, like Unicode or Wiley. So developing is kind of experimental at the moment, and pick an export format. XML is page XML.
So
right.
we have about 3 more minutes.
Sorry?
About 3 more minutes.
3 more minutes. Well, okay. We can look at the settings. No. Yeah. No, of course it will be multilingual. We have to implement the language and such. So yeah. So strictly speaking, that's it from my side. Yeah. So we can use it for questions, you know.
So, questions? All right, here.
Very simple question. Interlinear lines with OCR. If you have interlinear lines, you have a way of taking care of this?
Like Chan? Chan?
No. Yeah. Notes. Yeah.
No, annotations between lines, clauses.
Yeah. Not at the moment. That's something we have to look at in the future. Yeah.
Are you planning to incorporate into the app like some basic text critical analysis? So for example, if you took several editions of the same text, OCR, and then the app would tell you what different variables lie?
Not planned at the moment. So the idea is really to get this tool set out and wait for feedback, and then let's see to which extent we can extend it, perhaps. But it's not a feature that's just planned as of now. Yeah.
It's an intriguing idea.
Yeah, sure. I mean, yeah. But
Can we use this app for Sanskrit manuscript?
well, technically, you can plug in a model for another language. That's not a problem per se. We just don't have a model for Sanskrit at the moment. But actually, because the line detection is just looking for a line, so we tested it on Sanskrit materials by ourselves, and it works on the images I tested it with. So it will detect it, will extract the line, and then you just have to plug a Sanskrit model into it, and you get some output there. Of course, letting aside all the difficulties that are associated with it. But from a high level, yes, sure.
Thank you. I hope to see some Sanskrit. Sanskrit.
Can you manually correct if you spot an error, say, in the OCR? Can you manually correct from the app?
Yeah, that we can add that. That's not a big problem. Could be a feature. Sure. Yeah. No problem.
But if it's done in the app, it wouldn't necessarily go back and inform the overall model.
No, that feedback mechanism is not there. But yeah, the other apps can do that. So you can click on the line, correct it. That's not. Yeah, you can put it on a feature list.
Last call. Okay. Let's thank the speakers.
Okay, thank you.